Yeah.
I'm Miss L, and this is our TAKS prep class, and we are reviewing Objective 8 over three-dimensional shapes and finding volume and surface area. What I have come up with is a 4-step process on how to tackle these three-dimensional shapes. And so we first made a foldable, an envelope fold that's covering each of the 4 steps, and now we're going to do a sample problem that goes through each of the 4 steps. Okay, so if you can take a look at the sample problem that will work together. We're going to first do a rectangular prism. And I'm going to read the problem first, and then we'll walk through the steps together. It says, what is the volume of this solid? So we're first going to find the original volume, and then it's going to ask us to change something. What is the volume if the length, the width, and the height are doubled? So then we'll have to find a new volume. So okay, step 1 of our 4-step process is going to be to shade your bases and to decide what your shape you're dealing with. We like the rectangular prisms because they're all rectangles. It makes it kind of easy. So we'll go ahead and shade these two and say these are our 2 bases. And that way we know our 2 bases are rectangles. That way we know we're dealing with a rectangular prism. So then we can go to step 2 and find the formula for this problem. So we go to our formula chart, and we realize that we want the volume, because it tells us it wants volume. We want the volume of a prism, and that's going to be V equals big B times H. Okay, so we need to write that down. Okay. The second step is going to be to fill in the given information. And so we have here a big letter B, and we know to leave that to last. And so we're going to go fill in our smaller letters, which is going to be the height. We know that the height is going to be the distance between our 2 bases. So we want to go ahead and fill in 8 inches as our height. Okay. Our final step is going to be to deal with this capital letter. If we have a big B, then we need to find the area of our base, of our 2-dimensional base shape. And so we put the big B on our formula chart to remind us that we're going to refer back here. So our shape is a rectangle, and we know that we get that area by doing length times width. So if we go back to our original problem, our length and our width are 5 inches and 10 inches. So we can plug that in here. Okay, if we do that math, our volume is going to be 400 inches cubed. Okay, and it's cubed because it's 3-dimensional. All right, on to the next step. What is the volume if the length, the width, and the height are doubled? So we need to go back to our original numbers, and we need to double them. So this would be 10, this would be 16, and this would be 20. Same idea goes. It's going to be the same formula. We're going to go fill in our height because it's given to us. Doesn't require additional work. It's going to be 16 this time. And then to find the area of our base is the same, length times width. So we put in 20 times 10 and then times 16. Okay, and I'm going to need a calculator probably. Can somebody grab the calculator and calculate that for me? 200 times 16. This will show us the difference between the 2 volumes. The problem in some cases may ask you to go a little bit further and actually tell the difference. This just wants to know what the new volume would be. And in this case, our new volume would be 3,200 inches cubed. Okay, and that's the end of our first sample problem.